Hey, what's up, students? Here we go. This is the page 3 of the midpoints and distance formulas lesson 4 notes. Talk about the distance formula. It's probably one of the scariest looking formulas, but I'll show you a nice little shortcut here that makes the formula really not too bad. I really don't take my time and write the whole thing out. I just know the math and I just do the math instead of doing the formula. That's kind of the nice thing about math sometimes and formulas is you don't always have to do the formula, but if you do the math of the formula, you'll get there all the same. So here we go. If you have points A and B, such that they each have coordinate points, which they should, so we'll call it x1, y1 for the first coordinate point, x2, y2 for the second coordinate point. The distance of A, B, that's what this says. Remember, if you see just the lone points all by themselves, no symbols, nothing else on top, that's just asking for the distance. The distance of AB is going to be the square root of all of this noise, x2 minus x1 squared plus y2 minus y1 squared. What? Here's a shortcut. What you need to do, friends, is with mental math and a little bit of brain power, find the x distance. How far apart are the x coordinates from each other, as if they were just on a number line. So it's no different than going back to the first page. If you just ask yourself, well, how far apart all those? Remember, there's no such thing as a negative distance, so it doesn't matter which one's first, which one's second. How far apart are those? Okay, so that's what I mean by the x distance and the y distance. Find the distances. So find a number for this and a number for that. Okay, a little bit of mental math. You can always use subtraction to find distance. You square those numbers, you add those numbers, and then you square root the sum. So not really square root them, because after you add them, you'll get a sum. So technically that would be more like square root whatever number you get here, square root the sum, okay, when you add them together, okay? And then that'll be your answer, all right? So that's basically what all this math says. Find the distance. That's what subtracting the second one from the first one, the new one minus the old one. That's a distance. That's a distance, excuse me. In order of operations, you would square them next, and then you would actually add them. There's a plus sign, it says add them. And then, of course, the big old square root symbol means you save that for the end. So here we go. I'll do the formula, and then I'll do the shortcut, and then you can pick which one you like most. When you're solving for distances, okay, looks like we're given the instructions to go to the nearest tenth. It's the first decimal place. Okay, here we go. So what's the distance between these two coordinate points? Okay, here we go. Here's the first one. Why is it the first one? Because it's the first one I see. So this would be x1, and this would be y1. This would be x2, and this would be y2. It's the first x and y I see. It's the second x and y I see. So based off the formula here, I would set it up like so. I would do x2 minus x1. So I would go 4 minus a negative 7, put them in brackets, square them. Then I would do this. I would do y2 minus y1, bracket, square it, write the whole thing out. So after this, sorry I had a quick interruption. I needed to help somebody, so now I'm back at it. Okay, so let me double check. What did I do here? So I did x2 minus x1, okay, and then I did y2 minus y1. Okay, so pay attention to positives and negatives, so be careful. So I set it up just like it goes. Put brackets around it, and then I put squares and addition, and here we go. So now I'll just do order of operations one thing at a time. Brackets, so in here, when you do 4 minus a negative 7, that's actually addition, okay? So 4 plus 7, I believe, is 11. So right here I'll have 11 squared plus, see, negative 3 minus 5 more is going to be a negative 8. Now watch this, friends. Negative 8, what do you mean by a negative 8 squared? Now be careful, whenever you square negatives, you must always, always, always use brackets. Look at this calculator right here. Negative 8 squared, negative 8 squared. You must do this method right here because you can't have anything that's negative when it comes to a distance. And plus, when you square root something in brackets, you need to square the entire number. What happens here is your calculator thinks of this as negative space 8 squared. So it squares the 8 and then it keeps it negative. Here, it makes the negative be a part of the square. So if you take negative 8 times negative 8, then negatives would cancel. And then here, the negative is kind of outside the bracket, so it doesn't have to follow the rules. This negative is not affected at all by the square, hence why it stays negative. Little mini lesson right there. Okay, so negative 8 squared. So here we go. I got to do all that noise here really quick. So let's see, 11 squared, that's 121 plus negative 8 squared turns into a positive 64. That's what my calculator just said. Still got to square root all that noise. 121 plus a 64, according to the calculator, is 185. Running out of room here. I do the square root of 185. Here we go. Square root 185, please. Kaboom. 13.6 and noise. So the first decimal is 6. This is a 0, so the 6 stays. Remember, if this next decimal was a 5 or more, you would round up. But since it's a 0, keep it a 6. So it's going to be approximately a 13.6. All right. Here's a shortcut. Ready? Here we go. So I like to organize it a little bit. Just do an X, just do a Y. Okay. X distance and Y distance, here we go. So I ask myself, on a number line, how far apart are the X coordinate points? How far is a negative 7 from a 4? This is 4 away from 0, and this is 7 away from 0. Together, those distances would make a distance of 11. Again, spatial sense, common sense. If I drew a number line, 4 and negative 7 are 11 away from each other. No such thing as negatives. On a number line, how far apart is 5 and a negative 3? This is 5 away from 0. This is 3 away from 0. No such thing as negative distances. That's 8 apart from each other. Here we go. X distance, Y distance. Square them, add them, see what we get here. Oh, weird, 185. Square root it. It'll be about 13.6. See that? Way more efficient. Way more efficient. Instead of writing out all this noise, I jump right to the actual math and what it wants me to do. All right? Then I get 13.6, the same as the formula method. Okay, so again, how does that work so fast? X distance and Y distance. You find the distances relatively quickly. Takes a little bit of brain power, a little bit of spatial sense again. Take the distances, square them, add them, and then when you add them together, you can square root that. You can, if you are very confident in your calculator skills, you could actually do the whole thing at once in your calculator. So watch this. Square root. Let's see here. The first distance was 11. 11 squared plus 8 squared. Make sure the bracket goes over all of those things. Ready, set, boom. Oh, isn't that pretty? Isn't that beautiful? Look at that. 13.6. Okay. X distance, Y distance, square them, add them, square root them, boom. Find it in no time. I'll do the student practice here in a second.